My project was to use a Z80 and an external EEPROM chip, as well as some input and output hardware to create a memory monitor using the Z80 architecture. This would enable me, in summary, to write programs on the Z80, read memory, edit memory, and execute those programs all from the Z80 itself using no external hardware. This would be done by using a keyboard and a terminal-like output to a monitor or to UART or whatever. So the plan was to hook up the Z80 to a keyboard and implement three functions. There would be a read function, which would enable me to see the contents of the EEPROM chip. There would be a write function allowing me to modify the contents of that chip. And then there would be an execute function, which would allow me to run the program and execute the program that I'd written. This is very similar to Wozmon by Steve Wozniak. In fact, that is the inspiration for this project. Now, as you'll find out through my explanation here later in this video, you'll see that it didn't quite go as planned, and there were a lot of obstacles that I did not foresee, many of which had to do with hardware in particular. I did end up getting a working demo on the Nucleo board to show the functionality I was aiming for and to get the logic required in place so that I can, once the hardware is finished, implement everything on the hardware and get the system running. But again, there were a lot of very frustrating hardware setbacks and a lot of challenges that I did not plan for. And so I will go through and explain those as well as show the demo of what the project should have done. Conceptually, the project was fairly simple. In reality, there were a lot of variables, a lot of hardware issues that prevented this from happening on the time frame that I wanted. It still will happen, but I ended up having to go for a working demo on the Nucleo prior to getting the hardware to work, which in some cases is better because now I have all of the assembly framework that I wrote before, incomplete but still there. And I have a working C program that does the same thing that I wanted. And I just need to kind of smash them together and get the hardware working. Now, architecturally, there's a couple things with the project that went wrong. I'm going to go ahead and diagram that here. So we had our Nucleo. We had our Z80. And we had our EEPROM. These shared a bus. So this was the data bus. Yeah, I guess this was bidirectional. And this was bidirectional. So the data could go either way on this bus. We also had an address bus. This could output, and this only output. This does not read. And so what I would do is I'd use the Nucleo to program the EEPROM, and then using the control signals from the Nucleo, set the Z80 loose and let it do its thing on the EEPROM. There'd be other things, other involvement with the Nucleo. For example, using the USB, I'd have to tie the USB to the Nucleo because the Nucleo is the only board in this situation fast enough to handle the USB protocol even at low speeds. And then the Nucleo, using a custom or generic serial or parallel communication interface, would send that data to the PIO. The PIO would also send back the response to the Nucleo, and the Nucleo through UART would send it back to the computer so that I could see the output of the program. Now, the massive wall that I hit in this project happened right here, sharing this bus. And it happened for a multitude of reasons. Bus management was one of them. Managing the bus between the two things ended up being, honestly, it was very foreign to me. And so it ended up being quite a hassle. Eventually did some research, found out that the control line could be used, I could use the control signals to my advantage here. But another thing that ended up putting a very big halter on this project was the Z80 itself. So it exhibits, at least the chips that I'm using, exhibit some very strange behavior that I still have not quite figured out how to predict. I hook up all of the control signals, I pull up things like reset, so all of the control signals are active low. I pull things up like reset, I pull up halt, or wait in this case. The halt is an output. I pull up the interrupt requests, the non-maskable interrupt request, everything that would prevent it from working. I pull those up. I hook reset up to a button so that I can control it. I hook various other signals up. I hook the read up to the EEPROM. I hook the M request to the EEPROM. That signals that there's a valid address on the bus. All sorts of things. I hooked everything up. I hook up all of the address lines. I hook up all the data lines. Everything's all fine and dandy. But things just don't work like they should. And upon further testing, lots and lots, hours and hours and hours of testing, believe it or not, probably along the order of 10 to 25 hours of testing, with just the Z80 and the Nucleo, I ran into a couple problems. One of them was that occasionally the chips didn't function as intended. They were really finicky. I couldn't figure out why the hardware was being unpredictable because it was hooked up correctly, double, triple checked. The program was written correctly. The timing was correct. Things just didn't work. The closest I got was getting back to the original hardware that I used that did work, which had 10 kilo ohm resistors tied to all of those control signals and all of the address lines to the Nucleo and the Z80 and all of the data lines tied to ground, just straight tied to ground. But there's still some constraints here because originally, because of time constraints and because of the difficulty with the hardware, I was just going to use the Nucleo as the source of the memory, the interrupts, the I/O, and everything. But none of the GPIO ports on the board seemed to have worked because port B, or port C specifically, the one I was using, worked fine except for PC14, which would occasionally go high and stay high, even though it was configured as an input. All of the mode registers and everything were set correctly. It would just occasionally decide to go high and stay there. I would have to unplug the board and plug it back in, and it would go low, and then after a little bit, it would go high. Port B can't be used because PB11 is not on the board. Can't access it. PA can't be used because I don't have access to all 16 of those for the simple fact that I'm using PA2 and PA3 for UART. And there are no other ports big enough to handle a 16-bit address bus. So this is essentially where the progress stopped. I'm now going to demonstrate exactly how this project was supposed to work using PuTTY to connect to my Nucleo. So when I reset the Nucleo, it brings up a prompt with the colon showing that we're ready to go. There are three commands. There's write, read, and execute. They're all specified by a single letter. Now, in the back end, which I'll show in a second, I've got a various way of determining how these commands work, but it takes a certain number of arguments separated by spaces. So the first one is the write command, just the letter W, and you're going to specify an address, so I'm just going to do address 0. And as of right now, we only write with ASCII, so I'm just going to do hello world. So it's going to write hello world to address 0. Now, how are we going to figure out what's at address 0 now? There's a read command that I can use, and I specify an address and a number of bytes I want to read. So it's going to read out all of the data starting at that address, going for that length. So you can see here it went the first 128 bytes, split into 16-byte lines here with the ASCII on the right. And then for functionality's sake, this does not actually execute anything, but it does loop through until it reaches a specific character, the caret. So I'm going to write this at address 255. We're going to write caret at 255. And what the run command does is it's going to loop through memory starting at a certain entry point until it reaches a caret. So it's going to be X for execute. So we're going to start at 0, and it's going to run until it reaches that caret at 255. And the reason that I did it like this is because in all reality, once this goes to the Z80, it will be incredibly easy to swap that out for real functionality. Because once I feed it that entry point, instead of looping with that entry point until a certain point, I just pass program execution to that address. And so it'll actually be phenomenally easy to implement that as an actual function on the Z80 system. Now, in the code, I've written this with C, and I've written a string splitting routine to split a string by a delimiter. And then this parses that line, and here's our control loop.